Dear students, welcome back. This is Dr. Biju Vasudevan. This is the only video for week number 14 for Calculus 1, Math111, in which we are going to discuss only chapter 4.5 applications of maximum minima, applied maximum minima problems, right? The chapter rectilinear motion has not been included for your final exam. So, this week concludes with this chapter. Let's start with the applications of maximum and minimum. The procedure, what to do is just go through it. We will use it directly in the problems. Find a number in the closed interval. Find a number in the closed interval. Okay, it's not clear what is closed interval. The closed interval should have been, okay, I'll write here, this is 1/2 to 3/2, such that the sum of the number and its reciprocal is as small as possible, as large as possible. There are two cases. Okay, we have to take two numbers in this interval. See, this interval is half to 1.5, 0.5 to 1.5, isn't it? So find a number in this interval. If the number is x and if its reciprocal is 1/x, then the function what we are looking for to the sum of the function and its number and its reciprocal is our function, isn't it? Y. The sum of the number and its reciprocal, y, is x plus 1 by x. Y, we can call it f of x. Maximum value, minimum value as small as possible, maximum value as large as possible. So to find maximum and minima, we need critical point and end points. Find f prime. This is 1 minus 1 by x square when you differentiate with respect to x, isn't it? Okay, now let f prime is equal to 0. It will get you 1 by x square is equal to 1. So x square is equal to 1. X square is equal to 1. X is equal to plus or minus 1. See, negative 1 is not in the interval, so obviously the critical point is x is equal to 1. For x equal to 0, the function will be infinity, but x equal to 0 is not included in this interval. See? So this is also not a critical point. The only critical point is x equal to 1. So now we have three values of x. X is half, lower limit. X is 1 critical point. X is equal to 3/2 upper limit. Now find f for three values. For x equal to 1/2, what is f? 1/2 plus 1/2, which is 2. 2.5, isn't it? 2.5. For second value, what is f? When x is 1, 1 plus 1, it is 2. For third value, what is f? 3/2 plus 2/3, which is 6. 9 plus 4, 13/6, just 2.16 something. So out of the three values, what is the maximum, what is the minimum? Minimum of f, yes, there is y minimum. Y minimum is 2 when x is 1. You can say f maximum is 2.5 when x is half. X is half. That is the answer. Let's go to the next problem. How should two non-negative numbers be chosen? So two non-negative numbers be chosen so that their sum is 1. 2. Let x and y be two non-negative numbers. So sum is 1. What you get is x plus y is equal to 1. And the sum of their squares is as large as possible. So we are supposed to find the maximum minimum values for sum of the squares of the number. So let's take z or w as x squared plus y squared. This is what to be maximized and minimized, isn't it? So from this find y. This is section number. Y is equal to 1 minus x. Use this one in this equation. So z will be x squared plus 1 minus x whole square. Now z is a function of x. This is what we are going to maximize and minimize. So differentiate z with respect to x. You get why don't you expand it? Better expand it first. Z is x square plus 1 minus 2x plus x square. So z is 2x square minus 2x plus 1. Now differentiate z with respect to x. It is 4x minus 2. So first derivation should be 0. Z prime should be 0. Let therefore 4x minus 2 is 0. 4x is 2, x is equal to half. So we got x, and second derivation of z will be negative 2. So 0 so minus what is happening when you differentiate this one? This is 4 minus 0. So this is 4 positive. So at x equal to 2, if this is the critical point, the critical point is x is equal to 1 by 2, but the second derivation is positive. So at x is equal to 1 by 2, you get the maximum. When x is positive is minimum, isn't it? So we get the minimum value. Is that minimum will be attained at them. So where is the maximum? We will find it, right? So now how many x values are? What's the interval actually? What's the interval? The sum should be 1. Two non-negative numbers whose sum is 1. So x and y cannot be greater than 1. X and y should be inside the 1, lesser than the value of 1. So the interval for x should be 0 or less than 1. So the closed interval that we have is 0 and 1, and x is 1 by 2. Now we have three values of x and z function. This is z function. Now let's find the maximum and minimum values. What is z? Z is 2x square minus 2x plus 1. X values are lower limit 0, critical point half, and upper limit 1. Now find z at 0. What do you get? 0 is 1. Z at half. 2 into half square minus 2 into half plus 1. This is minus 1 plus 1 is 0. This is 1 by 2. Z at 1. 2 minus 2. 2 minus 2 will be plus 1. Will be 1, isn't it? So z at 0 is 1. Z at 1 is also 1, isn't it? When x is 0 and 1, you get maximum value. So is it maximum is equal to 1 when x equal to 0 or 1. Therefore y equal to 1 or 0. Z is minimum half when x is equal to half, and of course then y is also half. That's it. Let's go to the next problem. The boundary of a field is a right triangle. So we have a triangle, right triangle. This is the field, isn't it? With a straight stream along the hypotenuse. Hypotenuse is a river. The hypotenuse side has been bounded by a river stream, and with the fences along. So you are going to fence only these sides. No fence in the hypotenuse, isn't it? Fences along its other two sides. So let this be x and this be y sides. The triangle is A, B and C. Find the dimension of the field with the maximum area that can be enclosed by using 1000 feet fence. So when this total feet, the fence is 1000 feet, then what is the maximum area, isn't it? So x plus y is given as 1000. This is given first. So what is the area of the triangle? Area, you can take this as our function. Area is to be maximized, maximum area, isn't it? That is the function. Half into x into y. But y, what is y? Y from 1, y is 1000 minus x. So f, the function for area, is half x into 1000 minus x. Multiply inside. So 500 x minus x square by 2. When you differentiate, this will be 500x will be 500. This will be minus 2x by 2x. So first derivation gives you this one. F dash equal to 0 gives x is equal to 500. X is equal to 500 is the critical point. So and f double dash will be -1, which is less than 0. Therefore at x is equal to 500, the critical point, we get maximum. We get a maximum because second derivation is negative gives maximum when the critical point is given, isn't it? So obviously we don't want the end points. We found maximum at the critical point. So we don't want the end point. And we can say when x is 0, y is 1000. When y is 0, x is 1000. The interval is 0 to 1000. This okay. So x is 0, x is 1000, x is 500. There are three values to find, but straight away we can go ahead with the 500 because of the rule. So when x is 500, we will find the maximum area. So what is y? When x is 500, obviously gives y is also 500. So the function gets maximum when x and y are 500. So half into 500 into 500. What is it? 125,000 square feet, isn't it? So this happens at x is equal to 500 and y is equal to 500. That's the end of this problem. Another problem is a rectangular plot of land is to be fenced, again fenced using two kinds of fencing. So this is the rectangular field. This side is x, this side is y, isn't it? And this side is also x, so this side is also x. There are two sides which is called x, there are two sides which is called y. So total perimeter will be 2x plus 2y, right? Two opposite sides will use heavy duty fencing, which is expensive, for $3 per foot, isn't it? So let it be x. So 2x for 1 foot they are spending $3. Therefore 2x foot opposite sides, isn't it? So okay, let's finish. While the remaining two sides will use standard normal fencing for $2 per foot. What are the dimensions? The question is what is x and y of the rectangular plot of greatest area. So area should be maximized. Area is x and y. Now we need to find y from the another information. That can be fenced at the cost. Total cost is $6,000. $3 will be spent for one foot, but the opposite sides take x, 2 times x, isn't it? And $2 can be spent for y. That there are two y's, 2y. $2 per foot. There are y foot for this side and y foot for this side, isn't it? So 2 into y totally. This one should be equal to total expenses $6,000. That is 6x plus 4y is equal to 6,000. So we need to find y to use in equation number 1. 4y is 6,000 minus 6x. Y is 6,000 divided by 4 minus 6 over 4 times x. So what is y? What is y? Y is 1,500 minus 3x over 2. Now let us use this equation in equation number 1. Therefore area function will be x into y. 1,500 minus 3x minus 2 over 2. So area, you can call it function f hereafter. 1,500x minus 3x square over 2. This is the function which is going to be differentiated. Find the differentiation f dash. 1,500 minus 6x divided by 2 minus 3x. And find let f prime is 0. What do you get? 3x is equal to 1,500 gives x is 500. Obviously second derivation. What is second derivation? F double dash. See, this is constant, this is negative. So f get negative 3, which is negative less than 0. Therefore at x equal to 0, x equal to 500, a critical point, the only critical point. At this critical point, function gets the maximum. So we don't want the end points. As per the rule, if the second derivation is negative, we get maximum. If second derivation is positive, we get minimum. So we get maximum here. So we don't want the endpoints. Though we can find the endpoint, we don't want it. So x equal to 500. What is y? Use equation number 2 to find y. That is y, and then use in the area formula. You will get the maximum area. You can finish the problem hereafter. I will. So find y in using this one, and then use x and here find the maximum area, isn't it? That's it. Next problem is a rectangle is to be inscribed in a right triangle having sides of length 6 inch, 8 inch and 10 inches. So this is the triangle with the sides given 6 inch, 8 inch and 10 inch, right? We are inscribing a rectangle here inside it. Now we find, see, this is our outer rectangle ABC. There is an inner rectangle DEC. Now we know ABC and DEC are similar triangles. So the ratio of the sides will be equal 4. So we can write DE is this side, and which is proportional to AB. So DE over AB, the ratio is equal to other sides ratio CE, this area, this side, and BC. Now let's find this is take the sides of the rectangle as x and y, this side as x and this side as y. Obviously if the total distance is length is 8, this part will be 8 minus y, isn't it? and this part will be, this part of the side will be 6 minus x. 6 minus x, isn't it? Okay, we actually this is x, then this is also x. This is this part will be 6 minus x. Actually this is x. Fine. Now DE is x, AB is 6. Here CE is 8, this one 8 minus y, BC is 8. Now we will get the relation between x and y. Let's find y. But the question is, find the dimensions of the rectangle. So we got to find x and y with the greatest area. So the area of the rectangle is equal to x and y. The y should be solved from this equation. What is y? Find y here. This is, when you simplify this one, 8x divided by 6 is 8x divided by 6 equal to 8 minus y. Now this will give you y is equal to 8 minus 8x over 6. That is, y is equal to 8 minus 4x by 3. This is y used in this equation of a. So a is the function f x into 8 minus 4x over 3. So the function now it is 8x minus 4x square divided by 3. This is the function to be maximized. Greatest area, isn't it? So f dash will give you 8 minus 8x by 3. And f dash equal to 0 gives 8 is equal to 8x over 3 gives x is equal to 3. X is equal to 3 is the only critical point. And what is f double dash? Check. F dash is this one. So f double dash first term will be 0. F double dash is negative 8 by 3, which is less than 0. So when f double dash is negative, at this critical point x equal to 3, you will find a maximum. So we don't want the end points, isn't it? So when x equal to 3, use x here and find y. In this equation, find when x equal to 3, 3 over 3 will be cancelled. 8 minus 4, y is 4. So what we get finally, x equal to 3, y is equal to 4, x equal to 3. This is x and this is y, isn't it? Y equal to 4, x equal to 3. So the area is x into y. What is it? 3 into 4, 12 square units. That is the maximum area possible for the rectangle inside this given triangle. The last column, I think this is the last column. Find the dimension of the rectangle. I give an idea and you are going to solve this one. Find the dimension of the rectangle with the maximum area that can be inscribed in a circle. Generally, you remember one theorem. If you inscribe a rectangle inside the circle with the maximum area, then the rectangle must be a square. There is a rule. Actually, we don't want the rule right now. Actually, we can directly find the sides. We are looking for a circle given and a rectangle inside it, isn't it? So the center point, this is radius, r is given 10. So this side is also 10. So your diagonal is 20 units. And this sides x and y are unknown, isn't it? So the relation between, so now this 3 units, 20 x y from a triangle. So this will be x square plus, by Pythagoras theorem, x square plus y square is equal to 20 square. 20 square, isn't it? Now what we need to do is the maximum area. So area of the rectangle should be maximized. What is area of the rectangle? Area of the rectangle is x into y. So we call it a function f. Function f is x into y. Y can be found from here. What is y? Y square is 20 square minus x square. So y is equal to positive square. 20 square is 400 minus x square. This is y. We use this value here in function a, x into square root of 400 minus x square. So let us write f is equal to x into 400 minus x square to the power 1 by 2. Find the first derivation. To find maximum first derivation, x into okay, use any rule. Let's use product rule, isn't it? X into keep x and differentiate this one, half into 400 minus x square, half minus 1, and then minus 2x plus keep this 400 minus x square to the power half, and division of x is 1. So take LCM. This will be minus 2x square minus 2 and 2 will be cancelled, minus x square divided by 400 minus x square to the power half, because negative half will be there. Isn't it? X square, right? Minus 2x 2 plus 400 minus x whole to the power half. Take the LCM and cross multiply. You will get negative x square plus 400 minus x square divided by 400 minus x square to the power half. So that is how I am writing the top. F prime is, when you simplify this one, 2 times 200 minus x square divided by 400 minus x square to the power half. Let f prime is 0 to get the critical point, isn't it? The numerator will be 0, so x square is equal to 200 will give you x is equal to 10 root 2. 10. So x is found a critical point, or the only critical point, isn't it? Now let's see what is the maximum and minimum values of x. We can find second derivative and check whether it is negative or positive at x. That is also possible. But we can check x square plus y square is equal to 20 square. And from this one, if y is 0, x is 20. So the interval possible is 0 to 20. X is a side, so it cannot be negative. It starts from 0. Maximum value for so interval is 20. So there are 3 x values. X is 0, x is 10 root 2, x is 20. At these 3 points, find the area A and check where you get maximum. Probably at this point you will get to maximum, and then find the corresponding values. Thank you very much.